Good morning, everybody. We are starting a new topic called exponential functions, and we're going to talk about all the laws of exponents, lots of exponent rules today. So if you take a look at the do now, you can pause me right now and you could try to answer those first few questions, but each of them are displaying one of the laws of exponents. So in number one, I'm hoping you notice immediately you're seeing what operation. This is multiplication. So if you notice, you have coefficients and you have exponents, okay? You are going to, this is the product rule. You are going to multiply your coefficients, 3 times 2. You're going to keep your base. Your first base you come to is A. A base is what is being raised to a power. So what do we do with our exponents, 3 and 5? We add them. And we write our second base, B, and again we add them. 2 plus 3 is 5. And there you see the product rule. So let me just write that down. In the product rule, okay, remember product is your answer in multiplication. You are going to, step 1, multiply coefficients. Step 2, you're keeping the base. And step 3, you are just going to add your exponents. Okay, so take a look at number 2. In number 2, no more multiplication. Clearly here we are dividing. So this is called the quotient rule. Does that make sense? Okay, so in your quotient rule, you're going to divide instead of multiply your coefficients. So if you look at 15 divided by 3, those are your coefficients, you get 5. And hopefully you could see, instead of multiplying, we divide. Instead of adding our exponents, we're going to subtract them. So keep your base. 4 minus 2 is 2. And 5 minus 4 is 1. You could put a 1 there. Again, you're keeping your base and you're doing 4 minus 2. You're keeping your base of y and you're doing 5 minus 4, which is 1. You could put the little exponent of 1. I don't like to because you wouldn't see that in a multiplication, in a multiple choice question. So just know that. So 1, you're going to divide your coefficients. You are going to still keep your base, and you are going to subtract your exponents. Okay, now take a look at number 3. Number 3, you have 4c cubed d squared squared. So one way to do this is to take your 4c cubed d squared times itself, 4c cubed d squared. And really when you do that, when you expand it out, so I'm just going to make a little note. Really, when in doubt, just expand it out. Because when you expand it out, you're back to the product rule. You're going to multiply your coefficients and you're going to add your exponents, right? So I know most of you will tell me, okay, I can get 16, c to the 3 plus 3 is 6, and d to the 2 plus 2 is 4. But I want you to see one other option. Notice how else can you get 6 and 4 from the exponent of 3, 2, and 2? You could multiply. So this is called power to a power. And when you see that, you are actually allowed to multiply exponents. But what's the thing you have to remember? Be careful of your coefficient. Okay, see that coefficient of 4? So most people will just do 4 times 2, right? And that would not give you what you need. That would give you 8. You need 16. So make sure you're also not only multiplying your exponents, you are raising your coefficient to a power. If there is a coefficient, be careful, you have to raise it to a power. Okay, so let that soak in, and here I give you all your different laws of exponents. You have your multiplication, your product rule, your division rule, keep your base add, keep your base subtract, power to a power. You could see you're multiplying a times b. And then the other two, power of a product and power of a quotient, just understand that if you take xy, and you raise it to the a, it's really x to the a, y to the a. Same thing for quotient. If you take that whole x divided by y and raise it to the a, it's x over a divided by y over a. Okay, so let's do some practice. Okay, so here, straight division, you could write it like this, but remember that's a 1. So when you simplify that, you're really doing y to the 4 minus 1, y to the third power. Okay, everyone's going to get this one confused. Be careful. This 2 is not a coefficient. This is the base. So here, when you are, the coefficient is really a -1 and a +1. So really you are going to have a negative. You're going to keep your base of 2, and you're going to add your exponents. So you would have -2 to the 8th power. Okay, that was a tough one. Be careful. The 2 was not a coefficient, it was a base. In number 3, I would expand out. I would say, okay, -3x cubed times -3x cubed, and you would wind up with +9x to the 6th power. I'm going to leave that last one for you guys to practice. Okay, next thing we're going to talk about is following our exponent rules. What would we get when we simplify x to the 3rd divided by x to the 8th? So I know everybody would know it's division. So keep your base, subtract your exponents, and you get x to the -5th. Okay, we are not ever going to write an answer with a base and a negative exponent. We're going to rewrite x to the -5th, okay, as 1 over x to the +5th power. So here's what you should know. Anytime you are given a negative exponent, technically all you have to do is write its reciprocal, change its location. In the denominator, notice when I moved it down to the denominator, my exponent became positive. Now that works the other way as well. In other words, if I have 1 over x to the -5th down in the denominator, and I want to rewrite that, I could just rewrite it as x to the +5th up in the numerator. Okay? Does everybody understand that? So that's going to take a minute for you guys to let that soak in. You see some more examples down here. And I'm going to talk about one other thing. And I think most of you will know this. But remember, we've talked about this. Anything to the 0 power is equal to 1, not 0. And you could see that when you do x to the 4th divided by x to the 4th. Remember, the rule is take your base, subtract your exponent, you get x to the 0 power. Think about 4x is on top, 4x is on the bottom. They don't cancel. Any number divided by itself is 1. So just practice along with me. Look at the first 3 examples, 5, 6, and 7. A lot of them look similar. Anything to the 0 power, 5 to the 0 power, is 1. But look at number 6. What's being raised to the 0 power? Only the x. So technically that's 5 times 1, which would give you an answer of 5. Here, the whole thing, 5x is being raised to the 0 power. That answer is just 1. Okay, I'm going to let you guys practice 8, 9, and 10. And that's it. So I may do a couple more with you. So if you take a look at 11, notice only the n is being raised to the -2 power. M is technically being raised to the 1st power. Leave M alone. What do you want to do to n to the -2 power to make it positive? Drop it to the denominator, and there it is. It's positive. Same thing with 12. You have a negative exponent down here. You don't want that. How am I going to make it positive? I'm going to rewrite it up in the numerator. So a to the 8th power is how I'm going to rewrite that with a positive exponent. I just want to show you number 16. Very similar to 11. The 3 is not being raised to the negative 2 power. 3 stays in the numerator. But look, this x to the negative 2, I want to make it positive. So I'm going to drop it down to the denominator, and it becomes positive. Okay, so you could rearrange before or after, it's up to you. Even like number 13, you could do your quotient rule. You could either do, okay, let me see, a to the 2 minus negative 4 and b to the negative 3 minus 2 power. So be careful. This becomes addition, a to the 6th power. B, when you have negative 3 minus 2, becomes negative 5th power. That's not going to be an acceptable answer. A to the 6th, b to the negative 5th, you don't want this b to the negative 5th to be a negative exponent. A to the 6th is going to stay. But what am I going to do? I'm going to drop my b to the negative 5th power down to the denominator, and it automatically becomes positive. So see if you guys can do the rest, and I will post the answer key. Okay, have a great day.